And let's review our systems. So, first question says, solve by elimination. That means we're trying to add them together, and hopefully something goes away. But if you add them together right now, you get 5x and 9y, and nothing goes away. So, we're going to have to mess with this a little bit. What I'm going to do is look to see, like, does 2 go into 3? Can you multiply 2 by something to get 3? And I'm like, no. How about 3? Can you multiply 3 by something to get 6? Yes. But I really want it to be negative 6. If this was negative 6, then those would cancel. So what I'm going to do is multiply by negative 2. And you have to multiply everything by negative 2. So now this will be negative 2 times 2 is negative 4x. Negative 2 times 3y is negative 6y. Negative 2 times 12 is negative 24. Now I'm going to add those together. So I'm going to add these two lines here. If you're not sure what I'm adding, it's these two. So I'm just going to bring those out. When I add them together, the y's go away. That's the whole point. Negative 4 and 3x makes negative 1x. And negative 24 and negative 1 will make negative 3. So divide both sides by negative 1. Get x equals 3. Now, we got to take that and plug it in. I'm going to plug it in right there. So 2 times 3 plus 3y equals 12. 6 plus 3y equals 12. Subtract 6. 6 divided by 3, x equals 2. So our solution would be 3, comma 2. Okay, that's an order pair. That's where they intersect if you were to graph them both at 3, comma 2. You can check that by plugging it in right there. 3 times 3 plus 6 times 2. 9 plus 12 is 21. Hey, I knew we did it right. Let's try another one. Substitution. So if it says substitution, that means everywhere we see a y, we're going to replace y with that. Well, that means that we're going to set them equal to each other because they both equal y. So this is going to look like this. Negative 2x plus 3 equals x minus 9. So this is pretty easy. I'm going to get all my x's on one side. 3 equals 3x minus 9. I'm going to add 9 to both sides. 12 equals 3x. I'll divide both sides by 3 and say x equals 4. Now I'll come back and plug that in. Whichever one looks easier, probably that one. 4 minus 9, y equals negative 5. So 4 comma negative 5 is our answer. You can check that. If you plugged 4 in right here, negative 2 times 4 is negative 8. Negative 8 plus 3 is negative 5. Hey, that means I know we did it right. Cool. All right. Now this one you can choose. I don't care how you do it, but if it says choose and you have a y equals, you should probably do that. I'm going to substitute. I'm going to say 5x plus, but I'm not going to write y. I'm going to write what y equals 3x minus 4 equals 12. So the only thing that changed is instead of 5x plus y, I wrote 3x minus 4. Now I can combine my terms. 5 plus 3 is 8x. I can add 4 to both sides. 8x is 16. I can divide both sides by 8. X is 2. Cool. Now I'll plug that in. 3 times 2 minus 4. 6 minus 4 is 2. So that means y is 2. So the answer is at 2, comma 2. And I'll check it by plugging that in right there. 5 times 2 plus 2. 10 plus 2 is a 12. So I know I did it right. Alright, so those are solving linear systems. Done that before. Now, what if I give you a linear and a quadratic? Well, I'm giving you the table, and I just want you to tell me where they intersect. The easiest way to do that is to plug these in to that. So I'm basically going to make a table for negative 4x plus 1. I'm going to plug in all those x values to see which ones work. So x, and I'll say I'm going to plug in negative 2, negative 1, 0, 1, 2. So negative 4 times negative 2 plus 1 is 9. That means that one doesn't work. Negative 4 times negative 1 plus 1 is 4 plus 1 is 5. So nope. Negative 4 times 0 plus 1. 0 plus 1 is 1. Hey, that's 1. So 0, comma 1 is a solution. Negative that's also a solution. Sweet. Now, I don't think I can have a third solution because I don't think a line can intersect with a quadratic more than once. But just to be sure, let's plug in 2. So negative 8 plus 1 is negative 7. All right, well, that's not negative 5. So you find which x's give you those y's by plugging it into the line, and that'll tell you basically the solution set. When we say solution, that's where they intersect. So if I were to draw these graphs, I don't really know a ton about the graphs, but I know that at 0, 1, and 1, negative 3, they intersect. So it's going to look like something like this. And then you have a parabola that looks something like this probably. But they intersect in 2 places. 0, 1, and 1, negative 3. Alright, let's do, what else you got? Okay, solve the nonlinear system. So here, this is like the other one. They both equal y. So we're going to set them equal to each other. 3x minus 1. And on the right side, I have 3x plus 8. And now I will get all my things on one side. Ooh, that goes away. That's kind of weird. Let's see what happens. Minus 8. Actually, if you have x squared, you don't have any x's, you can just add 1 to both sides and say x squared is 9. And then you can square root both sides and get x equals plus or minus 3. Or, if you went the other way, and I did subtract 8, you would have had x squared minus 9. And you have to remember that that's dots. X plus 3, x minus 3, because these are both perfect squares. And then x equals plus or minus 3 that way. That's what we're making the quadratic formula. I don't care. But at the end of the day, you're going to have to solve a quadratic. And if you only have x squareds, the easiest thing to do is to just solve it like that. You don't have to bother with fact. Alright, we got x. We still got to find y. So 3 times 3 plus 8 and 3 times negative 3 plus 8. I'm plugging it in here because it looks easier. So that's 9 plus 8, so 17, and negative 9 plus 1 is negative 1. So this is 3 comma 17 and negative 3 comma negative 1. That's where those two intersect. That's a line in a quadratic. They intersect in 2 places. Let's see. Is that it? Word problem. All right. So let's see. First of all, let's look at what we need. We're talking about student and adult tickets. So we'll say S is student ticket. A will be an adult ticket. So how many did I buy? Well, there's 15 people in the class. 15 people. It doesn't matter if they're students or adults. We have to buy 15 tickets. So the first equation would be A plus S is 15. You gotta buy 15 tickets. It doesn't matter if you buy 15 adult tickets, 15 student tickets, or some mix of them. You gotta buy 15 tickets. Now we gotta look at money. So what do we know about money? I spent 132 bucks, $8 for students, 14 bucks for adults. So it's 14 bucks for every adult ticket and $8 for every student ticket, and they total $132. Now I have my system. I just got to solve it. You can solve it however you want. I feel like doing elimination. So I'm going to cancel out the s's. I'm going to multiply this guy by negative 8. I'll write that right underneath. So now it's negative 8a, negative 8s, and 8 times 15 is 120. Use your calculator. Now I'm looking at, just so you understand, I'm looking at those two equations now. When you add those together, 14 minus 8, you get 6a. Those cancel out. 132 minus 120 is 12, which means I bought 2 adult tickets. 2 plus S is 15. That means I had to have bought 13 student tickets. So I'm buying 13 student tickets and 2 adult tickets. And you should probably write that out as a word problem, so maybe a word answer would be good. Mr. Y bought 2 adult tickets and 13 student tickets. Okay, that'll be a fun little thing. Alright, so that's crash course. That's everything you will need to be able to do for your test. If you can do this, you're going to do well on the test. So,